Good evening, ma'am. I'm Joseph D. Machado Jr. from BCE 1B, Lecture 3. That's from the topic Work and Kinetic Energy, Problem Set Number 1. Check your understanding. 7.3, page 335. Find the work done by the same force in example 7.4 over a cubic path. Y is equals to the quantity 0.25 m negative square x cubed between the same points. A is equals to 0, 0, and b is equals to 2m, 2m. So this is my derivative, my Venn diagram given, which is y is equals to 0.25 m negative square x cubed, and a is equals to 0.00 is the midpoint, and b is equals to 2m, 2m, 2m is ym, and 2m which is xm. Then the 7.4 over a cubic path is force is equals to quantity 5n over m multiplied by yi plus the quantity 10n over m xg. Find is equals to w. Solution: express y and dy in terms of x and dx, which is y is equals to 0.25 m negative square x cube. So atong gamiton og power rule. Dy is equals to 3 times 0.25 m negative square x squared dx. So the infinitesimal element of the work is dw, which is gamiton nato og the basic of derivatives, which is the product rule of derivatives, bracket f times x g times x bracket is equals to f times x g times x plus f x times gx. So fx dx plus fy dy is equals to quantity 5n m y dx plus 10 over m x dy is equals to 5n over m. So 0.25 negative square x cube dx, which is y, plus 10 over m 3 times 0.25 m negative square x cube dx is equals to 1.25, and then multiply this 5n over m. The result is 1.25 n over m cube x cube dx plus multiply this 10 n over m. Then the result is 7.5 n over m cube dx, m cube x cube dx. So the result is 8.75 n over m cube x cube dx. So the integral of x cube is x cube plus 1 over 3 plus 1 is equals to x raised to the power of 4 over 4. So work is integral 0 to m 0.75 n over m cube x cube dx is equals to 8.75 n over m cube x raised to the power of 4 over 4. Integral 0 to 2 is equals to 8.75 n over m cube. So 16 over 4. Nakuha na to ang 16 over 4, which is the 4 times 4 is equals to 16. Then bring down the 4. Then the answer is work is equals to 35 joules. Continuation of problem set number 2. Check your understanding. 7.4, page 337. Question number 1. The spring in example 7.5 is compressed 6 cm from its equilibrium length. Does the spring face to do positive or negative work? And what is the magnitude? A. The spring force is opposite direction to an compression, as it is for an extension, so the work it does is negative. The continuation, problem set number 2. Check your understanding, 7.4, page 337. The spring in example 7.5 is compressed 6 cm from its equilibrium length. A. Does the spring force do positive or negative work? And B. What is the magnitude? So, this is the Venn diagram. My answer is the spring force is the opposite direction to an compression, as it is for an extension. So, the work it does is negative. So, batay sa akong pagsabot, ang puwersa tagsibol ay kabaliktaran sa direksyon sa isang extension, kaya negatibo ang gawaing ginagawa nito. Then sa B, the work then depends the square of the displacement, which is the same for the displacement, which is sum for the work is 1/2 kinetic, and kinetic energy is equals to multiplied by x square sub b minus x square sub a is equals to 1/2 multiplied by 3n over cm times bracket multiplied by 6 cm square minus 0, so 54 joules. So ako po sa ano ang isa ka trabaho nga gahimo nagdepende sa displacement nga parehas. So the work is 0.54 joules. Problem set number 3. Check your understanding, 7.6, page 340. You are rowing a boat parallel to the banks of a river. Your kinetic energy relative to the banks is less than your kinetic energy relative to water. Are you rowing with or against the current? Kinetic energy relative to the bank is less than to kinetic energy relative to the water, so therefore the velocity of boat relative to the bank is less than to velocity of a boat relative to the water. So this is the velocity of the boat, water. Then this is the velocity of water. Then the velocity boat of the bank is less than to velocity of the boat of the water. So the gravitational of velocity boat of the bank is equals to gravitational of velocity boat of the water plus velocity water of the boat. So the velocity of the boat relative to the bank, then the VWB is equals to velocity of the water to the bank. Then the velocity of the boat relative to the bank is equals to velocity of the water to the bank minus velocity of water to the bank, which is velocity boat of the bank is less than to velocity boat of the water. So it is happen only when you are rowing boat against the current. So akong pagsabutan kuan ang tubig siya gyud pareha kay maglutang siya. So ang tendensya na maglihok-lihok, so mo-gain siya sa current. Next is the network and particles motion, Problem set number 4, example 7.9, page 343 to 344. The frictionless track for a toy car includes a loop. The loop of radius r. How high measured from the bottom of the loop must the car be placed to the start from rest on the approaching section of track and go all the way around the loop? So this is the Venn diagram given, which is the formula is mg quantity y sub 1 minus y sub 1, y sub 2 minus y sub 1 is equals to 1 half mb square sub 2. So where the notation is shown in accompanying figure. At the top of the loop, the normal force, gravity are both down and the acceleration is centripetal. So a top is equals to force over m, which is equals to n plus mg over m is equals to v square sub 2 over r. The condition for maintaining contact with the track is that there must be some normal force, however slight, that is n greater than 0. So we're going to substituting for v square and n. We can find a condition for y sub 1. So solution, implement the step in the strategy to arrive at the desired result. N is equals to nmg plus mb square sub 2 over r is equals to negative mgr plus 2mg. The quantity y sub 1 minus 2r over r is greater than 0. Y sub 1 is greater than 5r over 2. Lastly, the last number, problem set number 5. Check your understanding, 7.7, page 344. Suppose the radius of the loop in example 7.9 is 15 cm, and the toy car starts from rest at height of 45 cm above the bottom. What is its speed at the top of the loop? So this is our Venn diagram, our given y sub 1, which is equals to 0.45 meter. Then y sub 2 is equals to 2 is 1.15 centimeter point meter. Then y sub 2 is 0.30 meter. Then our solution is negative mg, the quantity y sub 2 minus y sub 1 is equals to 1 half mv square sub 2. Negative mg, the quantity 2r minus y sub 1 is equals to 1 half mv square sub 2. Then we will going to transpose the mv square sub 2 over m is equals to negative 2mg. Substitute ka po na ito siya. Balhin na ang 2 mag-una. So 2mg equality 2r minus y sub 1 over m. Okay, ato gi awating m. So human square root of v square sub 2 is equals to square root of negative 2g negative 2r minus y sub 1. Kaya nga naman, kay gi-minus na ni siya ang m ug m. So ang mabilin g. Next is v square minus square root of negative 2g over 2r minus y sub 1. So, v square is equals to negative 2, which is negative 2, 10 meter per second square, multiplied by 0.30 meter minus 0.45 meter. So, v sub 2 is equals to negative 20 meter per second square. Okay, multiply na to ang 2, negative 2 times 10 is equals to, ang magkuwas, negative 20 meter per second square. So, multiplied, so i-minus po na to ang kuan 0.30 o 0.45, ang magawas is negative 0.50 meter. So, is equals to negative, is equals to square root of 3 m square over 3m square per second square. So, ang atong answer is v square over square root 3m meter per second square. Nahimo na siya kay ato gi cancel out ang square root og 2. So, ang mabilin, square root of 3 meter per second square. The speed at the loop, top of the loop is square root 3 meter per second. That's all. Thank you.